that you learned in Algebra 2. Nothing is different, okay? The only thing that you have to remember, and we talked about on the notes yesterday, the argument must be positive, okay? That does not include 0. It must be positive. The argument has to be greater than 0, not greater than or equal to, greater than 0. And that goes for the B also, the base and the argument. Today when we do some of the solving ones, yesterday when we did the solving ones, sometimes that ends up being negative. That doesn't mean negative answers don't work. It just means when you plug the answer in, it must give you a positive number. Okay, so if the argument was x plus 12, then x equals -5 would work, because -5 doesn't make that argument negative, right? Now for laws 1, 2, and 4, this left side is the condensed version. It's all the way condensed as much as you can. The right side is the expanded version, expanded all the way. Law 3 isn't really expanded or condensed. It's just saying if you have log base b of an argument equals log base b of a different argument, those two arguments are equal, so you can set them equal and solve, just like when we had like bases. 2 to the 5th equals 2 to the x plus 3. We can set those exponents equal and solve for x. All right, so here it says evaluate. Now, you might have to evaluate each individually. You might have to combine and evaluate. You might have to do a combination of that. So this one, we could say 4 to the what equals 2, 4 to the what equals 32, but that's not that easy because those don't really, 4 can't be written as 2 to something. So the easiest thing to do here would be to make that log base 4 of 2 times 32, which is 64, and then think 4 to the what equals 64, and then you get your answer of 3. So this is the work that I would expect right here. Okay, I would want to see that work and then the answer. If you're subtracting, that would be log base 2 of 80 over 5. It's not log base 2 of 80 divided. We can't change a minus sign to a division sign. We can divide the arguments, though. That's different. So 80 divided by 5, whoops, not 5, is 16. This would be the work I would expect to see right there. If you need to write 80 over 5 and then 16, that's fine also. And then I'm saying 2 to the what equals 16, and you get 4. Notice I'm not saying x equals, there's no x in the problem, okay? It's just what does this equal? 2 plus 3, what is that? It's 5. It's different than x plus 2 equals 3, then you're solving for x. This one, so all of these, there's lots of different ways to go about doing them. So if you go about it a different way and get the same answer, just like I always say, that is okay. This one, what I would do is probably bring that 3 down using my law number 4. And then notice this right here is that, which is 4. So 3 times 4 is 12. If you thought of changing that 16 to a 2 to the 4th, you could have done that also. This right here, you could have changed to log base 2 of 2 to the 4th to the 3rd. And then you can use your log base 2 of 2 to the 12th, log base b of b to the x equals x, and you get 12. Okay, another way to think of that. Whatever comes to your mind. Now just expand. So just using those laws to expand. This is 6 times x. So log base 2 of 6 plus log base 2 of x. How we can expand that. Now, how do I know if I keep going or I stop? So this argument right here, 6, is all by itself. Now, could we change that to 2 times 3? Sure, you could keep going, but there's no need to do that. Okay, you can if you want, but you don't have to. It's all by itself. It's raised to the first power. The x is all by itself. There's nothing being squared, cubed, square root, anything. So everything's all by itself. So that's how you know you're done. If the argument is not all by itself, then there's something else that we can do. Now, this one I'm going to do in 2 steps. Some of you might be able to do it in 1 if you're good at laws. You can do it all in 1 step, but if not, break it up into 2 steps. We're just multiplying, so that's add. Anytime you're multiplying and it's in the numerator, you're multiplying, meaning it's in the numerator, everything's plus. Anytime you have something in the denominator, the leading coefficient there is going to be negative. And now we have to go 1 more step because it's not completely done. 6 log base 5 of y. This argument x all by itself, y all by itself. So you are finished. Dividing means anything in the denominator is minus. So that's natural log of x minus natural log of y to the 1/2. This argument's by itself, but this argument is not. So we need to go 1 more step. Natural log of x minus 1/2 natural log of y. So there the arguments are all by themselves. Now, if that had been natural log of the square root of y, we would have had to change it to the 1/2 and then bring that out. So be careful, the square root is still not all by itself. It has to be completely by itself, out from under radicals and everything. All right, so this one I would do, could be done a couple different ways. You could square each of those terms, x squared, y squared, w squared with z squared, or what I would do is bring that out so I don't have to do that all those times and make it look like this. Now, that log xy over wz, xy is in the numerator. So if I took away this wz, it'd just be log x plus log y. This denominator, they're both in the denominator. So even though they're being multiplied so they're added together, but they're both in the denominator, so anything in the denominator needs a minus sign. The easiest way to think about these is if you're expanding a log or natural log, the numerator has plus signs, the denominator has minus signs. It's going to be the easiest way to remember. But we're changing this one thing into 4 different things, so it's 2 times anything in the numerator is positive, log x plus log y.
Would you come off if we did 2 log x plus 2 log y?
No, I'm going to do that in a minute.
Okay.
So yes, I'm going to actually distribute that here on my next step. But you can do it all at the same time too. So minus log w minus log z. Now, earlier they said, well, w and z is being multiplied, so why is that not plus? Well, because it's in the denominator, so it's minus both of them, and if it's minus both of them, that minus has to be distributed to both of them. So that's why. And we don't want parentheses, so this would be. And again, I'm doing this in a bunch of steps. If you can do a couple steps at a time, that is fine. And this one is kind of teacher preference. Really, I would accept either one of these answers. It kind of depends on the book, what simplified really is distributing the 2 or not. Either one of these answers would be okay. Okay, leaving that 2 on the outside or distributing it. And usually, most books and teachers say just get rid of all parentheses for it to be completely expanded. But again, I would accept either one of those on that answer. All right, combine. So now we're putting it all the way together. Now, the thing about the word combine, simplify, evaluate. So if I say evaluate, you're going to have a value. You know for sure there is a number that is going to be at the end. If I say combine or simplify, then maybe there's going to be a number at the end, but it'll be very apparent whether you should keep going or not. Okay, so when you get to when you see these, you'll see it'll be very easy to tell, do I keep going or can I not keep going? All right, log base 5, both of them are log base 5, so that could be log base 5 of 2 times 3, which is 6. So do I keep going? 5 to the what equals 6? That's not anything that we know. So hopefully that is very apparent that you stop right there. If this was log base 5 of 25, 5 to the what equals 25, then we could keep going. All right, here's our rule about anything positive goes in the numerator, anything negative goes in our denominator. So now we're just working backwards. So log, numerator is 3 times 6, denominator is 2. So that's just undoing what we just did in that last, second to last problem. So that is log of 9. 10 to the what equals 9? We have no idea. So you're done. If that was log base 9 of 9, then we could say that's equal to 1. All right, so on these, because of this 1/3 and this 2, we have to deal with those before we can do anything with the argument. So we have to say this is log of 64 to the 1/3 plus log of 5 squared. Because we can't use law number 1 if there's a number out in front. There's no numbers involved in there. It has to be just log. 2 to the 1/3 is the same as the cube root. So this is log of 4. This is log of 25. Now we can say this is log of 100. And that's something we know. 10 to the what equals 100? 2. All right, so letter D. You could distribute that 1/2 at the beginning or the end. I'm going to wait till the end, so I'm going to leave that 1/2 right there, and I'm going to combine these. Remember, positive, positive, positive goes in the numerator. Negative, that argument goes into the denominator. And then one more step of condensing, mn over p, all raised to the 1/2. Or you could say m to the 1/2, n to the 1/2, p to the 1/2. Or you could say log of the square root of mn over p, or the square root of mn, or the square root of p. Lots of different ways. There's really no single way that one is more simplified than the other. Either one of these are completely equal answers. One is not more right or more simplified than the other one on this right here. Again, either one of those is okay. All right, so yesterday's notes, when I redid the notes, I changed a few. I took some out of the notes. I put some problems on yesterday's that you couldn't do yet. Okay, so there's 3 problems from yesterday's notes that require you to use these laws. So this is letter B from yesterday's notes. Using our law number 2, we can say this is the natural log of x minus 5 over x equals the natural log of 23. And now, according to law number 3, since we have natural log of something equals natural log of something, those two somethings are equal. So we can say x minus 5 over x equals 23. And then we can cross multiply or multiply through by x, however you want to do that. So 23x equals x minus 5. Subtract x, 22x equals negative 5. And then divide by 22. And you get x equals negative 5 over 22. But you have to be careful on these, because when you look back at the original one, you have to make sure this doesn't make an argument negative. Because we just have a plain x right there, we know that negative answers will not work in this problem. So that does not work. So our answer for this would be no solution. Meaning if you graphed those two, they would never cross. That's what that means graphically. There's no number you could plug in where that would ever be true. Because the argument cannot be negative. Okay? And that's back, so here, m and n are positive real numbers. So this box right here at the beginning, they must be positive. M and n cannot be negative, or the argument can't be negative. So you always have to check whenever you have a variable as the argument, you always have to check your answers. All right, so we're adding. So that means multiply the arguments. So the natural log of 9x squared equals 2. Now, this one's not, we can't say 9x squared equals 2 because there's not an ln here. And we can't just put an ln. Okay, 2 doesn't equal the natural log of 2. So the easiest way to do this one is your little loop-d. So loop it and change it to exponential. So e squared equals 9x squared. Not the only way to do this, but I think it's the easiest. Now we just solve for x. So divide by 9. E squared over 9 equals x squared. Square root. When you take the square root, it's plus or minus. So x equals plus or minus. The square root of e squared is e. The square root of 9 is 3. But then check. But does it make it so when we plug it back in, they both work because our only x value is squared, so they both work. So that's what I meant a second ago when I said it's okay to have negative answers, you just can't have negative arguments. In this case, a negative answer would be okay because when you plug it back into the original, you square it, so anything would work in this problem except for a 0 if you got 0 as an answer. All right, adding, so that means we multiply, so that's going to be log base 3 of 24x squared minus 24 equals 3. Again, there's no log base 3 on the right. We could create a log on the right, but that's a lot harder, in my opinion, than just looping it. So 3 to the third equals our argument. So 3 to the third is 27. Don't get in a hurry and put 9 right there. That's a very common mistake, is multiplying instead of raising it to that power. Add 24. Divide by 24. Both are divisible by 3. Take the square root plus or minus. So you get x equals plus or minus the square root of 17 over 8. Because the original problem only had an x squared right there, positive and negative are okay. Now some of you like to rationalize. You do not have to rationalize, but if you do, plus or minus root 17, I'm going to change that 8 to 2 root 2 just so I don't have such big numbers if I want to rationalize. Multiply by root 2, multiply by root 2. I get x equals plus or minus root 34 over 4. Either one is okay. Don't want to rationalize? You don't have to. You want to rationalize? You can. Those of you taking calculus next year, it's the same thing. You don't have to rationalize, but if it's a multiple choice question and this is not a solution, you have to know that this is. Just like 1 over root 3 and root 3 over 3. 1 over root 2 over 2. We don't make you rationalize, but if that comes up, you have to know that they mean the same thing. In just an open-ended question like this, it doesn't matter which one you do. This is fine, or some of you like to rationalize because you don't like that radical in the denominator, that's fine. It does not matter to me. All right, and then the last part is just the calculator change of base. Now, back when I was in high school, which was a really long time ago, our calculators didn't do this. Okay, we had to use this change of base formula. And sometimes you need the change of base formula because you don't have a calculator, and the only way to simplify or evaluate or do anything is to use this. So, the change of base formula. How do you know if your calculator lets you do this or not? If you hit alpha window, Okay, so the green button and then the window right here next to y equals, and this box shows up, then that's good. If that box doesn't show up and it just keeps taking you to the window, that means either you have an old calculator that doesn't do this or your calculator needs to be updated, one of the two. Okay, and if your calculator doesn't do this, then you just have to use the change of base formula, okay, which is not difficult. Maybe you like that better than doing this right here. So alpha window, and then you have all these options right here. One of them should be log base. So when you hit that option, it's going to take you to the screen where you can actually put those numbers in. So whether you use the change of base formula when you're using the calculator, or you actually change the base because your calculator is automatically in base 10, then you can do this. Again, if you hit alpha window and that's not showing up, all that means is you have to use the change of base formula. That's what you got to do, okay, because you don't have this option on your calculator. You still get all the right answers, you just have maybe an extra step on some problems. So when you type all those in, this is what you should get for your answers. No matter which way you do it, your answer will be exactly the same, and we always round to the thousandths. The fourth place tells us whether the third place stays up or goes the same, stays the same. Okay? All right.